Hi, I'm Mr. Jake Gordon, and I'm going to show you how you can use mathsuniverse.com/LMC to write a program in LMC assembly code. I'm going to write a program which tries to find the minimum of two numbers input from a user. So I'm going to start off by getting rid of the program which is shown here. I'd like to say as well, I haven't pre-planned this, so I'll probably make mistakes on the way. Some of them will be genuine, some of them will be me showing you the kind of errors you might experience here. So we need to take two inputs from the user. So we get an input from a user using imp, which says takes an input from a user. A common mistake here is for students to write imp and then give a memory address they want to put the input into. But input doesn't take an operand. All input does is it puts a value from the user into the accumulator. Let's actually have a look at this running. We're going to make it run a bit quicker. And what we see is it asks me for an input. So I'm going to put in an input like 5. And it's putting that into the accumulator, but nothing's getting output at all. And we haven't put it into a memory address. So what we really need to do is put the input from the user into a memory address, and we can use that using the store command. So we're going to store it for now into memory address 2. So this is going to be where memory address 0 is, memory address 1, and memory address 2 is going to be below that. So let's try assembling and running our program again. And it's asking me for an input. I'm going to put in 6. And it's executing. There we go. It's put it into memory address number 0, 1, 2, and we can see that's got the number 6 in. This is the least significant bit and the most significant bit. So we've got 1, 4 and 1, 2, which makes 6 in total. So put it into that memory address. Now, it's not generally a good idea to reference memory addresses with their number here. So instead, what we do is we make a place to store data with dat, and we're going to store it into there. We give it a label at the front, so I'm going to call this A, as in this is number A. So we're going to store this into label A. I'm also just going to press space in front of these lines because I always like to have my optional label at the beginning of the line, then the instruction name, otherwise known as the opcode, and then the operand or the value that we're sending to that instruction on the right-hand side. So let's try assembling running this again. We're going to run it a bit quicker this time. It's asking me for a number. I'm going to put in 9. And we can see it's, oh, what's it done here? It's asking me for an integer again. I've made a common mistake here. It wasn't actually intentional. What's happened is it's looking at the next line after the store line, and it's seeing some data. It's actually looking at that number 9. And it thinks it's me giving it a new operation. So I'm going to pause the program, and it's really, really important before we have these dat lines that we have a line to halt the program. So what I'll often do is I will put my dats at the bottom, maybe a few spaces before them. They're not going to be put into memory, and really make sure that we halt before that. Otherwise, it's going to look at that dat line. It's going to think it's an instruction, see if there's an opcode for it, and try and run it. Let's try running that program again. I'm going to speed it up to full. And good. Okay, so we've got our input instruction here at the front, so 00001. We can see here that that is an input instruction. We've then got our store instruction, which is stored in memory here. The halt instruction is just a load of zeros, and when the computer sees those zeros, it's going to halt the program. But into the data, which is in the 4th memory address here, we now have the number which I just stored, which was 8. That's 8. No 4s, no 2s, and no 1s. And that's the number 8 that we've just stored there. And then the program halted because it saw these zeros and halted the program. So I've stored a number, and that's one thing we need to do. We want to try to find the minimum of 2 numbers. So we're now going to take another input from the user. I'm going to press space. I'm going to take another input from the user, and we're going to store this into B. And I need to make a dat labeled B here as well. Now we can optionally put numbers in here, denary numbers that we're going to start in these data locations, but in this case we're taking it from the user. I'm going to press assemble and run, put in 2 numbers, and we can see these 2 numbers are now stored over here in memory. But what we're trying to do is we're trying to find the minimum of these two numbers. So let me just think this through. So we've taken these two numbers, we've stored them. We need some way of comparing them and then doing one thing. We need to then load the smaller of those two numbers. So we're looking for something in terms of conditions. So if I was writing high-level code such as JavaScript or Python here, I would have something like if A is more than B, output B, otherwise output A. And the way we do those kind of conditionals or selection is with these branching statements. So there are three different operations that we've got here. We can always unconditionally branch. This will be where we don't have a condition, we're just jumping to another line of code. Maybe if in our high-level program we would have like, we'd be going into a function, for example. We've got BRZ. Oh, this is if the accumulator is 0. Remember, the accumulator is the CPU register over here. So if that's 0, we're going to branch to another line or jump to another line. And we've also got BRP, which is if the accumulator is positive or 0, we're going to branch to another line. So, but how do I actually see if one number is more than the other? We haven't got like a greater than or less than operation here. But what we do have is we have add and subtract operations. So if I subtract one number from the other, we could perhaps detect whether the answer is positive or not. So that's the approach that I'm going to use here. So before that halt line, let's just put that halt line down a few lines. We've stored both of these numbers. What I want to do here is take one number away from another. So I'm going to, how are we going to start this? So, well, currently we have the second input from the user. It's stored into this memory address over here, but it's also still in the accumulator. So if I have a look at the subtract operation, it says subtracts contents of a memory address from the accumulator. So if I subtract the contents of memory address A from the accumulator, that's the same as saying B minus A here. So we're going to subtract what is in the memory address labeled with A. So this is doing B minus A. Let's just run that program and see what we end up with in the accumulator. So I'm going to put in 8 for the first number for A and 5 for the second. And oh, we get a number starting with 1s here. And in 2's complement, that's telling us we've got a negative number. So we input, what was it? 8 minus, I've forgotten what I've input. Oh, it did actually say over there. Let me put this in again. Let's do 8 and 5. I can see here what my inputs were. 8 and 5, that was A and that was B. And I got a negative number. So in this case, I want to output 5, which is the one stored in A. So after that subtraction, we're going to have this branching. So we want to branch if positive. So if it's a positive number, that means that, let me just think about this. If this is positive, it means that B is bigger than A. So branch if positive to, where am I going to branch to? I'm going to make a line here and I'm going to label it B positive or B wins. Let's call this one B wins. And this line is going to it's going to load B into the accumulator, and then it's going to output that value, and then it's going to halt. So we're going to branch if it's positive to B wins, and if it's not positive, it's going to go to the next line instead, so where we are, and this is going to do the opposite of that, which is to load A and then output that, and then halt as well. So I guess we don't need this halt statement anymore. Let's expand the program a bit and press assemble and run. So we're going to take two numbers. Let's do 6 and 88. And it's outputting 88. I've got it the wrong way around at the moment. Let me try just doing it the other way as well. 88 and 6. Yeah, it's always outputting the highest number at the moment. So I'm just going to reverse the logic here. That's not B wins. Well, it is B wins, but we're going to call that B wins. We're going to load B. Well, yes, I guess B is bigger, but we're trying to output the minimum of two numbers here. So I'm going to call this instead B is, what am I going to call it? I guess I could just change what we're loading. Here we're loading B, here we're loading A. So this is, I guess we could call this A min, as in A is the minimum. So A is the minimum, or B was the maximum. And let's put in two numbers, so 66 and 4. We're hoping for an output of 4, we got it. Let's put in the other way around just to check, 4 and 66. Again, we're outputting the minimum number. I hope you found this useful as a way of learning about how to write assembly code. Remember that the web address of this simulator that I built is mathsuniverse.com/LMC. Thank you.